How are you guys? You alright? You need any help?
Yeah, a bit stuck.
Well, it's based on what we did. Like, remember, I worked out the mean and the variance of sample mean. I think it was on Tuesday or last week, maybe. I can't remember. It's in the written notes. If you look at the written notes, you'll see that I derived the mean and the variance. It's somewhere in the written notes. You remember, right? The expectation and the variance of sample mean. You do?
Can I show you the solution for the mean? Then check if it's alright.
You can take it if you know the.
Oh yeah, we do.
Yeah,
I just want to see if this is what we want.
Yeah, yes, exactly.
I make the same thing for the mean, and then I'm trying to calculate first x squared, and then with the x squared wrong is swapped in with that has 0.25, which is 0.25 and 2.
You don't need to do like that, Shama. Look, do it like, is it what?
Yeah.
So you want the variance of x bar, right?
Yeah.
Which is variance of 1 over 10 times the sum of xi. Yeah? And if you take the variance inside, it becomes 1 over 100 times the sum of the variance of xi. Yeah? Now, you know that for the uniform distribution, the variance of xi is, remember, xi follows the uniform 0, 1. So the variance of xi is, this guy is 1 over 12. If you know the formula, you forgot maybe the problem as well. The variance of a uniform 0, 1.
1 over 12 times e minus a squared.
Yes, which is 1. So it's 1 over 12.
Yeah, but can't you just find it like it?
Yeah, but that's will be long.
Yeah, but it's not working for me. I mean, why it's not working for me?
It should be.
What did you say?
But what I'm doing wrong?
What? What is not
You're not doing anything wrong, but it will be a long way to do it because you have x plus it will be pretty long.
Yeah,
This is long. If you use this identity, it's so much easier.
Yeah, I know, but I'm trying to do it like this, and
But like it will, you will at some point, if you will not ever do this.
what's wrong with this one exactly?
There's nothing
It's
wrong.
not wrong, but it's simpler this way.
Yeah, okay, but when I do it like this, I don't get this answer.
Oh, so that's how we do it.
I mean, I don't
Is this
get
alright? Let's see.
Hello guys, all of you done question 6. And you done 6 already?
So your variable x
Yes,
is
no.
x1 from
I know.
and when you make it squared, when you make x squared, it's here, the square here. That's why it's so much harder to do that. So you need to use this identity.
Find my glasses.
That identity, like,
Yeah, I know.
you're exactly like me. You don't never want to fight for someone. No. You start understanding. You make your own rules?
Yeah.
Now, guys, remember what I told you in the class.
I don't want to bring it back.
The question is to find the expectation and the variance of x bar.
But I use all
Do you guys remember the Do you guys remember the formulas I gave you for this and this? What's the formula for this, guys? Mu. And what's the formula for this?
Variance of f.
Sigma squared divided by
And
just 10 here, right? So we just need to work out the mu and the sigma squared, right? Where mu is the expected value of a single uniform variable. Now, if you look at the list of distributions I gave you at the first day, for a uniform 0, 1, this is a half, right? And the sigma squared, which is the variance of x, and for a uniform 0, 1, it is 1/12. This is where did this come from? The one of the handouts I gave you on the first day, right? Okay. So the answer is the expectation of x bar is 1/2, a half, and the variance of x bar is 1/. Right?
how do you know the variance is 1/12?
That's what I was saying, sir. There is a, if you look at the list, I gave you a list, all of you, a list of probability distributions on the first day. There is a formula on that list which says that for uniform 0, 1, uniform AB, it is b minus a squared divided by 12. Let me see. I have a pen. If you have x, which is a uniform AB, right? If it is a uniform AB, then the variance of x is b minus a squared. This is what I have used. Okay, you remember? I mean, that's one of the formulas in the sheet in the handout I gave you first day. All right, can you now? Is this okay, guys? Any questions? Hello, talk to me, guys. Are you okay? All right, can you do 7, please? Now, 7.
Work out the
What? Did you ask something? So basically, you have to find this one.
I just thought I'd been trying probability of X1 to 2 X3, so it's like floor code.
So it was a good question. Yeah, but it could be x6 equals +1. It could be
Hello guys, anyone who hasn't signed the attendance sheet, can you raise your hand? So, attendance sheet, can you pass it on here?
I always like 2 questions and so does that mean like it's more like the 12s?
How are you doing, sir? You okay?
Yeah, I'm okay, I'm fine.
So,
The formula is in the notes. The formula is in the notes.
alright, but I just have to search for it.
Ah, okay, okay, we can go.
So,
Alright guys, have you all done 7 guys? Anybody who hasn't done question 7? You alright? Okay, so let's see. Alright, you have. Hello guys, can you listen please? So the question is asking you for the joint probability. The joint probability is also known as the joint probability mass function because you are dealing with the discrete distribution. Alright, so the question is asking you for the joint PMF or probability mass function. Okay, which is the probability that capital X1 this is what the question is asking you. Because x1 to x5 is a random sample, it implies that they must be independent, right? And hence you can write this. You can write this as the product I from 1 to 5 of the probability that xi equal to little xi. All right. Now, I'm sure all of you know the PMF of the Poisson distribution. You did that in probability 1. or is in the handout I gave you. This is EF minus lambda, lambda power xi divided by xi factorial. Do you guys remember this or not? Okay. Now what's the product of, this is where, I think I mentioned this at least 2 times. A lot of people have trouble simplifying products of functions. Now what does it simplify to, guys? This will simplify to E of minus 5 lambda, lambda power x1, x5 divided by x1 factorial all the way up to x5 factorial. You get this or not? Now we are given the values for x1 to x5, which are 9, 13, 6, 8 and 10. Okay, so if you add those numbers, what do you get? The 9 plus, I'm not good in math. What do you get? What do you get if you sum these numbers?
49.
49. Okay. So this would be EF. I trust you, man. Blame him if it is wrong. Blame him. Okay. 49. Now what you need to do is you need to compute this at lambda equal to 10 and compute this at lambda equal to 2 and okay. I will leave that for you to do because I don't have a calculator. All you have to do is compute this at these 2 values, right? And pick the one that gives the larger number. Good. Right? I'm sure you can do that, right? So can you any questions, please? You have questions?
Like on a normal calculator, hand calculator, you can do that.
Yeah. I think so. Yes, sir.
You can't do it like that. You can do the top bit of the fraction, so you can still see which one's bigger.
Oh yeah, yeah.
But we don't.
You don't need to compute this part here.
Yeah, we don't
you only need to compute the numerator.
Yeah.
Because this part is independent of lambda. Right? So you only need to compute this multiplied by this.
We don't need to compute it 5 times 1 though. We can drop the 5 as well because it's 5 in both ways. And we need to find a bigger one so we can just find the ratio. And if it's more than 1, the numerator will be the bigger. And if it's less than 1, the denominator will be bigger.
I think you need the 5 too.
No, you need the whole thing. You need the whole numerator. You need to compute the numerator at lambda 10, lambda 12, and choose the one.
If we divide for 1 day equals 10 and 1 day equals 12, and we divide them, the 5 will go up on both.
No,
it
will
it
be
will not.
lambda 1 over lambda minus lambda 2 all to 5.
It will be.
All right, guys. Can you do question 3 now, please? Are you okay with this? Any questions on this, guys? Anyone has questions on this? Yes. Good, that's what the question is asking, ma'am. Which lambda gives the sample most likely to occur? That's the question. So that means the lambda that gives the higher probability should be the answer.
And now we take
right? Because you should read the question here. Which value of lambda results in the given sample being more likely to occur? Right? Are you okay? Any other questions, guys? Please.
That would be 8 to the 10.
Raise your hand.
Yeah, but
All right, can you do question 3, please, now? Question 3.
You don't need a 5. You don't need 5. You need a 5. Yeah. You could replace 5 with 3, for example, just function bigger in both. So that's why you need the 5.
Anyone else? Hello, guys. Anyone else? Are you okay, sir? Anyone has questions on question 7? You need to follow question 7. Anyone else who hasn't signed the end of the sheet?
What did I get more than?
I get 10.8. That's what we I have a question. What? Because here in the variance is 10.8 and the mean is 6. Is that normal? Like, the variance could be bigger than the mean.
Yeah, they are indefinite. You can have a sample with very big and the mean like the variance is
The mean can be 0, the variance can be 100. You know what I'm saying?
the mean. Oh, okay. The variance means how far they are far away. The mean is
It's over, isn't it?
Yeah.
Yes.
Roderick, for question 7, that's just using the likelihood function.
Yeah.
Okay.
We'll
so
talk
you
about it
could-
later. Yeah, it's basically a likelihood function here. But here you're asking for the joint probability, which is the joint PMF, right? So it's just the product of the Poisson PMF for x1 to x5.
Okay. Yeah.
Yeah,
So you could calculate the best lambda.
yeah, you
That's
could.
likely.
Yeah, you could. Yeah, but you will need to do it in a computer. You will need to you can do it for all possible values of lambda, and choose the best lambda, right? But you have to do it in a different way. That's the likelihood way.
Okay.
We will talk about it later in the course. Yeah. Yeah.
I think I've done the quiz. Problem 2 for the quiz.
Okay.
Do you want me to
Thank you, man. Thank you.
to the office or?
Yeah, it's okay. I will keep it. You don't have to walk to the office. You guys done too? Not yet. Take your time. Have a good weekend. All right, guys. Have you done question 3, guys? Let's see how we can do question 3. Right. The first part is to find the population mean. Now, what is the population mean? I told you in the class. What is it? is the expected value of x, right? That's the population mean, right? Now in this case, you have a discrete variable. The x values 2, 3, 6, 8, and 11. So it's going to be 2 times 1 over 5. Right? Do you see where this comes from? Yes? If you work this out, you will get the answer 6. So the population mean is equal to 6. Alright? Now, part 2 is to find the population variance, which is this guy here, which is this guy here. Now we know the expectation of x, which is 6. So the square of 6 is 36. Okay? Now to find the expectation of x squared, you do the same thing. So you do 2 squared times 1 over 5 plus 3 squared times 1 over 5 up to 11 squared times 1 over 5 minus 36. And you will get the answer 10.8. Yeah, you all got this right? You all got this correct, okay? Don't tell me you got a different answer. Alright, now, are you okay with this? Yeah, alright, let's go to part 3. So we are picking samples with replacement. Yeah. So how many outcomes can you have if you do it with replacement?
5 squared.
25. Okay. So the outcomes can be 2, 2, 2, 3, 2, 6, and so on, right? Okay, now I'm not going to write all the outcomes, but because I'm just lazy, it will take me whole day if I write the whole outcomes. Okay, you know what I'm saying. So now in this column, I'm going to compute the x bar. So what's the x bar for this?
x1 plus x2 over 2.5. Is it 2.5?
Yeah, it's
2.5. 2.5. 4 and so on. Okay, and the probabilities associated with each of these is
1 over 25.
Alright? Now once you got this table right, the rest of the question is just trivial, right? The question is asking you to find the expectation of x bar. Right? You can do it in two different ways. One is to use this table. So it will be 2 multiplied by 1 over 25, 2.5 multiplied by 1 over 25, 4 multiplied by 1 over 25, and so on. This is one way to do it, and you will get the answer. Let me check. You will get the answer 6. Alright? Of course. Okay? Alright, and another way to do that is to use the fact that the expectation of x bar is mu, which is the expectation of x, which is equal to 6. Of course, we know that. Yeah? So that's, you guys listen, please. The next thing is to find the variance of x bar. Are you listening to me, guys? Are you okay? What's the problem? So, one way to find the variance of x is to and the expectation of x bar squared, you can write it like this, is 2 squared times 2.5 squared times 1 over 25, 4 squared times 1 over 25, and so on, minus 36. Now, if you work this out, you will get the number 5.4. Alright, so this is one way to find the variance of x bar. Another way to find the variance of x bar is to use the formula sigma squared by n. What is your n here? 2, yeah, 2. Sigma squared we already know is 10.8 divided by 2, which is also 5.4. Alright, so we are done. So we are done with question 3. Can you move to question 4, please? Unless you have questions on this. Any questions on this, guys? Please. You're on. Question 2 is without replacement. That's the only difference. So you do, sorry, question 4 I mean. Question 4 is without replacement. So the outcomes will be different, but the process is the same. Yeah. Here with me, guys. So these are the outcomes. There will be how many outcomes? Yes.
I was going to say, how can we count like 2 and 8 and 8 and 2 different? They're not just the same.
They're not the same, yeah.
Right.
They're not the same.
So the order matters.
Yes. But you get the same answer if you take order not to matter. The answer will be the same. So the x bar you can calculate, the probabilities will be 1 over 20 all the way. Alright? And the calculations are the same as before. You follow what I'm saying? You calculate, you put the x bar here, the probabilities are all 1 over 20, right? And you do the same calculations as question 3. Yes?
Is this variance correct?
Probably 1 over 10.
I only want this side.
No. No, it's not. Maybe you made a mistake. Anyway, you know what to do, right? Or do I need to tell you more than this? Anyone has questions? No? Ma'am, you okay? So you just use this table to compute the mean and the variance of x bar. Same as before, same as the previous question. Okay? Alright guys, I will see you. What's the time now? Are we
How much?
Like usually you don't have to make all the calculations all the time. And when we make without mistake, like this, when you correct the variance of x, if you go to 25 squared times 25 the case that's are not because this one
No, you don't need to do it like this. Don't just follow question 3.
just make the calculation. Don't care
I don't know, but I would do it like this. I would do it like question 3. It's online, man. All the answers are online. You should go to the course web page. If you go to the course web page, these are the answers for question 3. These are all online.
Okay.
Yeah. Thank you, sir. Have a good weekend.
Can I ask a question?
Yes.
When you have the variance of x2, which is put replacement, without replacement, is it true that
No, x2 is just random variable. There's no placement there. They expect x1, x2 are just...
x1 is the first time one of the big,
Yeah.
and the x2 is the second that will be big? That's the without replacement.
But maybe it's different.
Because for x1 we have all outcome possible. For x2 we have all without one.
So what is saying?
x1 and x2 have different expectations.
No, they will have the same expectation.
It's just some of the
Because
numbers. If you sum 9
I do that on the picture.
take the train,
They have the same expectation. I'll show you.
I think yeah, you're right, I think. They have the same expectation, x1 and x2.
Like what? if the equation was different, why would it be different?
Say it's not probably not.
Because they have the same like.
It must be.
Because I'm just listening to this guy. I don't know, if you sum these numbers, 9 plus 22,